So one day I had an idea. What if I built my own weather station from scratch? Not just a basic temperature sensor with a microchip and call it a day, but a system that actually logs real data over time and transmit it over radio, so you can put it anywhere where you want to. Temperature, humidity, pressure, CO2, well, everything. And it stores it automatically on the SD card, so I can analyze it later. So the first step was of course ordering a few sensors. I ended up using those ones. A very precise temperature and humidity sensor, a very precise pressure measurement sensor, and a CO2 sensor. For the microcontroller outside, I wanted to use an ESP32. So the first phase of the project was basically just testing, for example how to get accurate data from the sensors. So I sat in front of my laptop for a few hours thinking about life and the nature outside and why I couldn't read data from the pressure sensor. Whenever a sensor worked on the first try, I immediately assumed that something was wrong, but fortunately the pressure sensor didn't work at all and I had to order a new one on AliExpress. A few hours later I finally got all the sensors working together, without the pressure sensor of course. A few weeks later the new pressure sensor arrived. I was very excited. Now I finally had all of the sensors which I needed for the weather station. Hold on. Is this a new version of the famous DPS 310? Or do you notice the small difference between those two modules? Oh my god. So I went onto AliExpress again and bought a third pressure sensor, which would take another eternity to arrive. This also reminds me of when I paid 30 euros for a UV radiation sensor and I waited a month for it or so to be delivered, and when the day came where it should get shipped to my door, the order got cancelled. Yeah, but hey, I got a $1 coupon, so that's something I guess. The inside unit consists of another microcontroller, the most accurate real-time clock which I could find, and an SD card module. Now the interesting part is how those two units talk to each other. For that I used two E220 long-range radio modules operating at 868 MHz. Apparently they can communicate over a distance of from 5 to 10 kilometers. I programmed everything in Arduino IDE and honestly the software part took a lot longer than I expected originally. Mostly because I spent more than 40 hours to figure out how I could use the ESP32 in combination with the two radios, because one radio suddenly couldn't receive anything. Until I found out that this radio was, well, dead. Yeah. I've probably shorted the receive pin a few weeks before and assumed that it was fine. The idea is that the master inside sends a signal to the sensor unit outside. When the outside unit receives the signal, it wakes up the sensors, measures everything and then sends the data back. Also, the outside ESP32 is in deep sleep most of the time, which basically means that the batteries will last forever, hopefully. The master receives the data and writes everything into a CSV file on the SD card, together with the timestamp from the real-time clock, so I can analyze the data in Excel later on. At this point everything worked, but the setup looks less like a weather station, more like modern art made of jumper wires. So can you guess what I did next? For designing the PCB, instead of placing every chip and every capacitors from all of the modules directly onto the board, I decided to use the modules that I had already bought to save on 3 AM nights painfully trying to figure out where that one datasheet was. So I designed custom footprints and also added some female pin headers so the modules can just be plugged in. That way they are easy to replace if something breaks. Designing the PCB was way faster than I expected. Let's just ignore the fact that I invested 4 hours to trying to figure out how I could connect the two PCBs with mouse spites because I was convinced that this would make the order cheaper. Until a few hours after ordering, Chelsea PCB sent me an email saying, yeah, nice try, that'll be 6 euros extra. This probably also led to my redeemed €5 coupon suddenly being ignored, so that's a pity. But eventually everything looked correct. It's not as if you should double check PCBs before ordering them. So I exported the files and ordered the boards. And 1.5 weeks later the PCBs finally arrived. And these mouse bites held way better than I expected. Now I had to solder all of the pin headers so I could stick the components on top. Is it just me, or why can't I cut the pin headers correctly so the ones next to the where I cut don't get shattered completely? So done. This is the moment of truth. Hold on. Do you see what I see? Why is the ground pad here, but the ground pin of the radio is on the completely other side? Wait. Let me check the other pins. No, I've just checked the footprints and there's some bad news. The pins of both of the radios and also the SD card modules are mirrored. You know what I'm gonna do? If I theoretically unsolder the pins of the modules and put them back on the other side, should this work? Maybe. Can any one of you tell me what soldering tin they used for mounting these pin headers? Because even with flux and 400 degrees, they won't even move a single millimeter. Nah, this is also not working. I think I will first have to wait for the new radio and the pressure sensor to arrive before I try anything. Okay, I have an idea. If I just solder the radio and the SD card module on the other side of the PCB, then it should work, right? Yeah, please don't say anything about the looks. Anyway, now there is only one right thing to do. Strange. Still doesn't work. Wait a second. Oh my. I just looked at KiCad on the PCB and I don't know how this could happen, but somehow the ground pin of the ESP32 is not connected to anything. I have no idea how this could happen, because you can clearly see that I did connect the ground pin. Yeah, but it's an easy fix. So this should be it. And I will just connect this and I will leave it here for the next couple of hours. So a few hours have passed. Let's see if the weather station actually works. Oh, wow, it works. Whoa, I didn't expect that after so many problems on the way. Now we can just create diagrams out of this. Wow, you can even see how the temperature has risen from the morning to midday. But why does the CO2 concentration fluctuate this much? Because it should be a very precise sensor. I'm using an SCD41. If you know, please write a comment. Yeah, I think this is just the beginning of a bigger project. I will probably add some more sensors, a display, and maybe a proper case in the future, because yeah, you can't leave a PCB outside like this. If you have any other suggestions what I could add, let me know in the comments below. I hope you enjoyed. Thanks for watching.